Hi everyone, this is Mrs. J, and today we're going to learn about complex numbers. So before we start the lesson, please pause the video and give this warm-up a try. Here you are solving 3 quadratic equations using the method of your choice. And then go ahead and hit play when you're ready to check your answers. All right, let's go ahead and check. For part A, I chose to solve this by factoring. So make sure that you realize that x is the greatest common factor and it needs to be part of your factors. And it does give us the solution that x equals 0, so don't forget to write it out front. For part B, I also solved this by factoring. You could have completed the square or done quadratic formula, but I think factoring is the easiest way to go. And for part C, I showed 2 different ways. You can factor this using difference of 2 squares, so pretty straightforward there. Or you can actually use the square root method, so isolate x squared and then take the plus or minus square root of both sides. So just remember, for all of these problems, you have lots of different options, so make sure you're familiar with all the different methods because it might save you some time when you're picking your choice. All right, so all of the problems, or the quadratic equations we've been solving up until now, have had some type of solution. But we know that it is very possible for a quadratic equation to have no real solution. What this would look like graphically, again, here's your x and y axis. A quadratic is just a parabola. So let's say you have a parabola that looks like this. This parabola never crosses our x-axis, and so therefore there's no solution. There's no x values that work. Or maybe you have a parabola that looks like this. Again, if it doesn't cross the x-axis, then it doesn't have a real solution. Today we're going to talk about, well, what do we do when we don't have a real solution? So here's what it looks like algebraically. So let's say we go to solve this. So we're going to subtract 9 from both sides. Say I choose to do the square root method. And then I take the plus or minus square root of both sides. So we get x equals plus or minus square root of negative 9. So algebraically, we know to stop here because we cannot take the square root of a negative number. It is impossible to do. So in the past, anytime that you came to this point in the equation, you were told to stop and write no solution. However, what if there was some way that we could take the square root of a negative number? So in math, we came up with a way to describe this situation. So by definition now, anytime we see the square root of negative 1, we're actually going to call it I. So we have a variable that represents the square root of negative 1. Now this I is called an imaginary number. So it's really important to remember in the back of your head, this is not a real solution. This is not a real number. In terms of real numbers, there is no way we can take the square root of a negative number. However, in Algebra 2, we start using this imaginary number, I, so we can still work with these types of problems and still get useful information. So here's how imaginary numbers work. Essentially, anytime you see a negative inside your square root, you're going to write an I on the outside. So the I gets rid of the negative. And so then this would just be the square root of 9, which is 3. So we say 3I. Again, this is not a real number. It's an imaginary number. Or let's say we have the square root of negative 8. So here we can get rid of the I, or we can get rid of the negative by putting the I out front. And then this we just need to simplify. So square root of 8 is 2 root 2, right? Because 8 is 4 times 2. So we could say 2I root 2. So we can still simplify these types of radicals, whether they turn into a whole number like this or if they still have a radical. But from now on, anytime you see a negative inside your square root, we're not going to stop. We're going to use imaginary numbers. So today, we're going to be focusing on what are called complex numbers. So complex numbers is any number that can be written in this form, a plus bi. So the a is what we call the real part. Notice there's no I. And the bi is what we call the imaginary part. So technically, to be a complex number, your a value could be 0. You don't even need a real part. Or your b value could be 0. You don't even need an imaginary part. Or sometimes you have both a and b. So those all fall in this kind of broad realm of complex numbers. So you can see we have 3 plus 2i, and then we have 5 plus square root of negative 15, which we know would become I root 15. Here we have negative pi, which is just some number 3.14 minus I. So these are all complex numbers. Now within the big realm of complex numbers, which pretty much covers anything, there are two kind of sub-realms. So there's the real part again, which describes that a value. So if you are considered a real number, you don't have I, you don't have the imaginary part. So something that is a real number is also a complex number. Notice this circle is still within the bigger circle of complex numbers. And then here we have imaginary numbers. So an imaginary number, or a pure imaginary number, is a term that has I. So notice that it only has that I term. So these imaginary numbers still fall within the category of being a complex number, but we can be even more specific and also call them an imaginary number. So here we're just going to start by looking at a couple different complex numbers and see if we can identify the real and the imaginary parts. So here we have 6i. So if we have 6i, if it helps, you can think of 6i as 0 plus 6i. So you can see here that the real part of the expression is 0, and the imaginary part of the expression is 6i. And again, it is still a complex number even though the real part is 0. Let's look at part B. So for this one, you could see that the real part is 7, it's that a value, and then the imaginary part is that b value, or that bi, so it's negative 3i. So real and imaginary. And then last here we just have 12. So again, if it helps, think of it as 12 plus 0i. It is still considered a complex number, so the real part is 12, and the imaginary part is simply 0. All right, so now we're going to talk about how to add and subtract complex numbers. So imaginary numbers like I, they're really easy to work with because they pretty much act like any other variable, especially when you're adding or subtracting them. We're essentially here just combining like terms. So in this problem, we have two complex numbers that we're adding. Since we're adding, these parentheses really don't do anything for us, so we can write it without the parentheses. And then again, we're essentially just combining like terms. So we can combine the real parts. Here, negative 2 plus 5 is 3. And then we can combine the imaginary parts. 3i minus 4i is negative 1i, so 3 minus I. All right, in part B, here we have 12 minus 6i minus 8 minus 3i. So here we just need to be careful that we're subtracting this entire second complex number, so we do need to distribute those negatives. So we can rewrite this as 12 minus 6i minus 8, and then it's actually plus 3i. But from here again, it's just simply combining like terms. So we have 12 minus 8, and then negative 6i plus 3i. So this gives us 4 minus 3i. There you have it. So again, adding and subtracting complex numbers or imaginary terms is really just like combining like terms with any other variable. All right, so go ahead and pause the video and give this one a try. And then when you're ready, hit play and you can check your answers. All right, so go ahead and check. For part A, you just need to be careful that you did distribute that negative. We're subtracting both terms, so it's minus 9 minus I. And then again, it's just combining like terms. And just for the standard form, we should always write the real part first. So it should be negative 9 and then plus 3i. Then in part B, since we're simply adding, the parentheses don't really do anything for this problem, so we can simply combine like terms, and you get 23 minus 4i. So while adding and subtracting with imaginary numbers is just like any other variable, when you're multiplying with I, it is a little bit different. So we do need to understand what these 4 different powers of I represent, and it will help us simplify an expression with I. So here, anytime you just have I to the first power or just I, we'll simply leave that as I. That's no problem. But anytime you have I squared, by definition, I squared is equal to -1. So anytime your problem has I squared, we always replace it with -1. Now, think about this. I cubed is simply I squared times I. So -1 times I would just be -I. So anytime you have I cubed left, we're always going to replace it with -I. And then I to the 4th power is just I squared times I squared. And -1 times -1 is +1. So I to the 4th power becomes +1. So anytime we're simplifying an expression with some power of I, our first goal is to take out as many groups of I to the 4th as possible, because I to the 4th is simply 1. And then we see what we have left over to see what we should replace it with. But the big one, the most common one you'll see, is I squared. I squared always becomes -1. Okay, so let's give some of these a try. So remember, for each of these, we're first going to try to take out as many groups of I to the 4th as we can. So if we have I to the 5th, we can take out one group of I to the 4th, and then that leaves us with one I left over, right? And that would lead us to I to the 5th. So again, this simplifies to 1, so it essentially disappears. And then this expression is simply I. So I is a simplified version of I to the 5th. Okay, let's look at I to the 14th. So if we have I to the 14th, we can actually take out 3 groups of I to the 4th. So I to the 4th, I to the 4th, and I to the 4th, right? That brings us to I to the 12th. And then what that has left over for at I to the 14th is I squared. So 4 plus 4 plus 4 plus 2 is 14. So again, this is equal to 1, this is equal to 1, this is equal to 1, and this becomes I squared. And then we just need to remember I squared always is equal to -1. Okay, for I to the 24th, we can actually divide 24 evenly by 4. So really it's I to the 4th 6 times, right? There's 6 groups of 4 in 24. So this expression is simply equal to 1. So anytime your exponent is divisible by 4, it will simplify to 1. And then this last one, for I to the 11th, we can actually take out 2 groups of I to the 4th. And that brings us to I to the 8th. And then that leaves us with 3 left over, I cubed. So again, this simplifies to 1, this simplifies to 1. What we have left is I cubed. Remember, I cubed always simplifies to -I. So now we know how to simplify higher powers of I. But again, the most common one we'll come across is simply I squared, which we need to know is equal to -1. So now that we know how to simplify powers of I, now we can multiply with complex numbers. So when we have 2 complex numbers that are being multiplied, we simply do our FOIL. We just are going to multiply it out like we would with any other 2 binomials. So for part A, we can start by doing 4 times 6, which is 24. And then 4 times -2i, which is -8i. And then we have 9i times 6, which is 54i. And then last, we have 9i times -2i, which is -18, and then I squared. Now here we can combine like terms and we can simplify. So these can be combined. So if we have negative 8i and positive 54i, I'll write the 24 first, that leaves us with 46i. And then the other really important thing to remember is that anytime we see I squared, it becomes -1. This is equal to -1. So it's actually -18 times -1, which becomes +18. And then here you can see that after we simplify that, we can combine these two terms right here. So we get 42 plus 46i. All right, let's try one more together. Again, we're going to do our FOIL. So first we have -2 times 3, which is -6. Then we have -2 times 5i, which is -10i. 4i times 3 is 12i. And 4i times 5i would be 20i squared. So in simplifying, we can combine like terms here. And that gives us positive 2i. And then we can also remember that I squared is always equal to -1. So this actually becomes minus 20. 20 times -1. And then we just need to combine like terms again. So we get -26 plus 2i. And then we're all done. All right, here is the last example for the video. So go ahead and pause the video, give this one a try, and we can check your answer in just a few moments. All right, so go ahead and check your answers. So your first round of FOIL should give you this, and then just remember I squared is equal to -1, so this actually becomes +7. So when you're done combining like terms, you should have -8 minus 26i. All right, so that's all for today's video. Thank you guys for watching.